The micrometer screw gauge. The micrometer screw gauge. The micrometer screw gauge. Micrometer screw gauge is a precision. Micrometer screw gauge is a precision instrument. Precision instrument used to measure precision instrument used to measure very small lengths such as person, the diameter of a thin wire, such as number one, diameter of a thin wire, thickness of diameter of a thin wire, thickness of a thin sheet. Micrometer screw gauge is a precision instrument used to measure very small lengths such as diameter of a thin wire. Next is thickness of a thin sheet. Then thickness of a metal plates. Thickness of metal plates. Diameter of a small sphere. Diameter of a small sphere. Right. So now we need to draw this instrument. Right. So figure is on page number 17. Right. They can come one page. And draw a very large one. Right, Adu. limit එක pass කරනවා. Good. Name the parts also. So remember, if the arrow is pointed to here, it is linear scale. If the arrow is pointed to here, it is sleep. Obviously, සමහර correct question එකේ එහෙම තමයි. මේකද method arrow එකේ තියෙන එකවත් linear scale. Linear or main scale. Linear or main scale. Thank you. Right now, the screw, yeah, I can tell you that. The screw is arranged. The screw is arranged. The screw is arranged inside the sleeve. The screw is arranged inside the sleeve, and the screw is arranged inside the sleeve, and the thimble is fitted. The thimble is fitted. Thimble is fitted onto. The screw is arranged inside the sleeve, and the thimble is fitted onto the thimble is fitted. Fitted. Savikar fitted. Onto the end of the screw. End of the screw. While the spindle is fitted, while the spindle is fitted, spindle is fitted onto its front. The screw is rotated by. The screw is rotated by. Screw is rotated by the thimble, and the screw is rotated by the thimble, and when it rotated, when it rotated, the screw moves. The screw moves forward or backwards. Forward or backward, depending on the sense of rotation. Next paragraph. The normal micrometer screw gauge is consisting. Now micrometer screw gauge is consisting a linear scale, which normally has a linear scale which normally has 0.5 millimeter divisions. That means the pitch of the screw is 0.5 millimeter. That means the pitch of the screw is 0.5 millimeters. A circular scale is calibrated. A circular scale is calibrated around the front of the timber. Around the front of the timber. And in the normal screw gauge, this scale has 50 equal divisions. 50 equal divisions. Right. Therefore, least count is least count equal, which is 0.5 divided 50. 0.5 millimeters divided by 50. Least count equals 0.5 millimeters divided by 50. Again, 0.01 millimeter. 0.01 millimeter. Next slide. The range of the micrometer screw gauge normally used is from 0 to 25 millimeters. From 0 to 25 millimeters. Right. Next sentence. The linear scale is marked on the sleeve and normally it has linear scale is marked on this sleeve and normally it has 0.5 millimeter divisions. A line marked along the middle of this scale. A line mark along the middle of the scale, and it gets covered by the circular scale. And it's covered by the circular scale when the thimble is rotated. So that line is this one, the center line. So when the thimble is rotated, it gets covered by the thimble, right? And the line they can cover it. Right. So makes sense. And the object need to measure should track between anvil and spindle. The object need to measure should track between anvil and spindle in order to get the measurement. For this purpose, spindle must be moved using thimble head or ratchet. Thimble head ratchet. Thimble head or ratchet thimble head or ratchet made for avoid the overpressing. The object measure. Avoid overpressing object which we measure from object measure. When the object is trapped, in between anvil and spindle, with standard pressure, ratchet will rotate freely by sounding tick tick. Here. 23 or 24 example. Sound it. Then how that sound up here. Sound in down. Tick tick. The sound in tick tick. The sound here the one tick 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 tick. Right. Okay. You know some main things, right? Then. Tick tick. How many sound there? Right. So now you know how to sound, right? Make a linear. Right, make it purposeful linear. The lock nut. What is the purpose of lock nut? Because the lock nut is used to hold the spindle in position. Lock nut is used to hold the spindle in position. Right. Then we move to the next part. The next thing is how you obtain a reading. How you get a reading from this instrument? How you read this? Right? Getting a reading, or either reading the value of the scale also has two parts, right? Like the vernier. If you remember, when you take the vernier readings, it has two parts. One is you need to take the main scale reading, then thereafter you get vernier scale reading, right? Here the same thing, but there's no vernier scale there. But instead of vernier scale, you have a circular scale here, right? So taking a reading from a micrometer screw gauge is, we can write it as an expression. First, you need to take the reading of the linear scale, right? So you need to take the reading of the linear scale. This LSR means linear scale reading. Then you need to add to it circular scale reading, CSR, right? So this is how you get the reading. First, you need to find out the linear scale reading up to nearest half millimeter. Then you need to add circular scale reading, right? Let's see. So by looking at the diagram, I've already drawn. So what is the value of the linear scale reading here? Up to closest, the nearest millimeter mark. So you need to check. Right now, there's no zero mark. You can see. You need to check whether the starting line of the timber is at. So you need to pick the closest millimeter mark to the starting line of the starting line of the timber. So what is the millimeter mark at here? What is the number of the millimeter mark? Vertical line in front of this vertical line. So what is the nearest or closest millimeter mark? Is it? Here it is 0. Then 1, 2, 3, and 4. You can't see any half millimeter marks in between there. Then half millimeter marks in there. Even a half and 4.5 now. 4.5 mark you can't see there. In here you can't see the 4.5 mark. So it is 4 millimeters and just something add to it, right? So you can rate the mains linear scale up to this millimeter mark. So it is 4 millimeter. It is 4 millimeters. Then how to get that extra small length? So this length, when the main length taken, when the main length taken, you cannot measure this length when the main gap taken. You cannot measure this length using linear scale, right? So we need to get the help from the circular scale. How we get that? How we get the circular scale? Tell me the method. Now you can see there is a circular scale division which is in line with the center line. At the beginning, when the two not the two jaws, at the beginning when the angular and spindle are in contact, right? So when you start the take measuring, when the angular and spindle in contact. So this is the positions of the scales. The position. This is center mark, center line, and you can barely see the zero of the main scale, and this is the zero of the circular scale. 4 marks. 1, 2. So this is the position where the anvil and spindle in contact. Right? So suppose now we want to move this spindle to the right side. So what is the direction you need to move this thimble head in order to get this spindle a little bit back? Anti-clockwise. Then, so if you have carefully look at the instrument I have given to you, so how the scale is calibrated? And when scale is calibrated, whether 0 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 45. So in order to bring this spindle or move this spindle back, you need to rotate this thimble this way. Maybe this way. Anti-clockwise way. Right? Suppose at the beginning, this is the way. The 0, 2, 0 marks, not the 2, 0 mark. The center line and the 0 mark of the circular scale is in line. Right? Now I have bring. So I have moved the spindle some distance to the right. Right? So now this is the center line. This is now you can see the 0 mark. And what distance are currently not up, right? So less than 5 millimeters, 0.5 millimeters, small distance there. So you can see the 0 mark clearly now. Right? Now, 0 mark of the circular scale is here. 1, 2, third division is in line with the center line. 1, 2, 3, 4, 5. Right. And there are another marks also. Right. In order to bring these scales, or in order to move this spindle this much, so I already turned this thimble. How many divisions? Initially 0 at here. Now the 0 has come to this point. Instead of 0, now center line is in line with the 1, 2, 3, third division. In a position division, anti-clockwise move in order to move the spindle this distance, I have turned the spindle. How many divisions? 3 divisions. 3 divisions mean 1. If you turn the 1 division, the screw has moved distance equal to the least count 0.01. Now I have moved 3 divisions. So how many distance? How many length? How much of length? 0.03. So you can get it by take the circular scale division in line with the center line, which is third here. So 3 into least count. 3 into least count gives you the circular scale reading. Right here. Now come back to this. Now tell me what is the circular scale reading here. How you get the circular scale reading? The simple thing you need to find out which circular division or circular mark is in line with the center line of the linear scale. All you need to find out the mark, which mark or which division is in line with the center line. Right? So, what is the number? What is the number? Can you read it? What is the number of the circular scale division which is in line with the linear scale? 33, 32, 32, right? It's 30, 31, 32, right? Then circular scale reading is 32 multiplied by what? Least count. Least count is 0.01 millimeters. So it is 4 millimeters plus 0.32 millimeters. The answer is 4.32 millimeters. That's all. Very simple. All you need to find out which circular scale division is in line with the main linear scale, the center line of the linear scale, and multiply it by the least count. Then you can find out the circular scale reading, right? Then add it into the linear scale reading, right? Before we move on to the tutorial, so tell me the reading at here. Right. Now tell me. So what is the reading here? Reading of this scale. Right. So what is the linear scale reading? Linear scale reading. 2.5. Okay. Here 1 millimeter mark, 2 millimeter mark. Then it has marks 2.5 millimeter marks also, right? 2.5 millimeters plus. So what is the circular scale reading? 35, 36, 37, 38 division is the mark which in line with the center line. So times 0.01 millimeters 2.5 plus 0.38. 2.88 millimeters. That's a reading. Right? Well, the topic is how to obtain a reading from the micrometer screw gauge. Micrometer screw gauge. How to obtain a reading from the micrometer screw gauge. Screw gauge. MSG is micrometer screw gauge. Right under it. Obtaining a reading from the micrometer has two parts. First, we need to find the linear scale reading. We need to find the linear scale reading up to the nearest millimeter or half millimeter. Millimeter or half millimeter mark. Secondly, we need to add reading of the circular scale. Reading of the circular scale to it. Reading of the circular scale is given by multiplying the number of the circular scale division, the number of the circular scale mark, which in line with the number of the circular scale mark, which in line with the center line of the linear scale from the least count. Right, write the expression. Write it as an expression. Everybody have make it here. Young number it is. Reading is equal. Reading equal. Reading equal. Write it as an expression. Reading is equal. Linear scale reading plus linear scale reading within bracket LSR. Linear scale reading plus circular scale reading. Circular scale reading. Right. So as an example, you can copy this figure and get a reading. This is as an example. Finish. Okay. Get the tutorial and go to the question number 2. Question number 2. Question number 2, part 3. Question number 2, part 3. On page number 20. I do the first 4 parts of it. Page number 20. Question number 2, part 3. Right? Do the first 4 parts. The given figures, right? Find the readings of micrometers given below. Right? Get the readings. Here there are no 0.5 millimeter marks. Linear scale is calculated with 1 millimeter marks, and circular scale has 100 divisions. But hurry up. Okay. Question number 2, page number 20, part 3. Part 3, first 4 questions. This one. Right? Finished? Oh. Start it. Right. So what is the first reading? Is it 6.75 millimeters? Main scale, linear scale reading is 6 millimeters, right? 6 millimeters, and 75 is the circular mark, circular division mark, sorry, circular scale mark in line with the center line. So 75 times 0.01, 6.75. Second one, what is the reading of the linear scale? Second, 6, 5. So here you see 5, can't see 6 there. I paid in hand 6 there, 5 in 5 plus circular scale reading is 65 times 0.01, 5.65. Is that 6? Sorry, 6. Sorry, 6. Right, 5.66. 66 the right. Is the third one? What is it? Main linear scale reading 0. 0 plus 74 times 0.01. 0.74 millimeters. Fourth one, 3 is the linear scale reading. 3 plus 98. 98 times 0.01. So it is 3.98. Let's get another one. Fifth come on. Take that. Fifth one. Is that same reading? Sixth again. Sixth again. Me. Shuffle. Sixth again. Linear scale 5 clearly paid. This one. Same micrometer. What is the linear scale reading? 6. And circular scale reading is 0.65. 6.65 is the answer. Right? Is that 6.65 millimeters? So that's it. Right. So now you know how to obtain a reading from this micrometer, and like the vernier, before you take a measurement, we need to check whether there is a zero error or not, because zero error is also relevant to this instrument. We did not discuss about the zero error for traveling microscope, because when you measure diameter or something from the traveling microscope, always we take difference of two readings. Therefore, zero error is relative to the both of the measurements. When you take the difference, error will cancel. Right? It is a big calculation. But here, before you going to take a reading, right? Before you measure the object or whatever you were provided to measure, you need to check whether there is a zero error or not. So how you identify whether there's a zero error or not in this micrometer? How you identify it? So first you need to close the jaws, or first you need to bring the spindle that it is in touch with the anvil. You have to get to this position. Now the thimble head is pretty moving. That means anvil and spindle now they are touch with each other with standard pressure. Right? Then, if there is no zero error in this instrument, the two scales, linear and circular scale must be positioned like this. If there is no zero error, you can see the half of the millimeter mark of the linear scale and zero mark of the circular scale also in line with the center line of the linear scale. So if there is no zero error of this instrument, this is the positions of these scales, right? So when you bring the anvil and spindle in touch with each other, if the scales are positioned like this, that means there is no zero error in this instrument. So that is fine. So we are lucky, no need to do adjustment to the final reading, right? But due to some reasons, right, like we discussed in verniers, right? So if the face of the anvil go at this phase, maybe there are some oxides or may the rust or maybe deposits here, right? So therefore, some thick layer is in between the anvil and spindle. So that makes a small gap, right? So sometimes anvil or spindle get wear and tear. So that may also makes over rotation, over rotated, right? So those two causes, right, are the reasons for the zero errors of this system, right? So like the vernier caliper, the zero error of the micrometer is also two kinds or two types. So it has a one type of zero error is known as positive zero error. Positive zero error. So how we identify the zero error is positive, right? Carefully. So this is how we identify the positive zero error. We can know positive zero error features here. Right. So you can see zero mark of the linear scale clearly go more than half of it. So here you can see half. If the error is positive, you can clearly see zero mark of the linear scale go more than half of it, because the thimble has moved some distance to the right. Right? Then the main thing is, if the error is positive, remember zero mark of the circular scale, zero mark of the circular scale is at below the center line of the linear scale. So it is at below. If the zero mark of the circular scale at below the center line of the linear scale, error is positive. So this micrometer is already given some reading there. Before you take the measurement, it can also at the beginning shows some reading there, right? So this is positive 0. If the error is negative, negative 0 error, this is how you find. So now you can assume what are the features. If the negative 0 error is there, negative 0 error happens when the symbol is over rotates. Now, can you see the 0 mark clearly? Right? 0 mark is active, it is less than half. Just you can see, oh, you cannot see the 0 mark. You can't see the 0 mark. And what can you say about the 0 mark of the circular scale? 0 mark of the circular scale is at above the center line. Here, 0 is there. If you over rotate this, clockwise, what happens if you rotate this scale clockwise? 49, 48, and A marks 0 will go up. 0 mark counted. Right? So 0 mark of the circular scale is at about the center line. So this is how we get it. Right. Now the next thing is how you find this 0 error. Positive 0 error. Finding positive 0 is same as you are taking a reading from the instrument. Right? So 0 error, positive 0 error. Positive 0 error. So how do you take the positive 0 error? You can take you can get the positive 0 error directly. Find the mark of the circular scale which is in line with the center line and multiply it by least count, right? So you need to find out the mark of this curve, mark or division of the circular scale which is in line with the center line. Here it is 1, 2, 3, third one into 0.01 is the least count. So positive 0 error is 0.03. How we get it? You can get it straight away. Find out the number of the circular scale mark which in line with the center line and multiply it by the least count. Right? Then how you find this? Can you use the same equation for the same expression? Is that here the 47th circular scale mark is in line with the main center line of the linear scale? Is that mean the 0 error is 0.47? 47 then? No. So what is the extra number of divisions that this symbol has rotated, over rotated? 0 needs to be here. But now it has gone to this place, right? So how many divisions, how much of divisions that 0 has over rotated? If you want to bring this 0 here, how many number of divisions you need to re-rotate? 1, 2. If you want to bring this 0 here, you need to rotate this symbol 3 divisions, right? 3 divisions. So you can take that 3, by subtracting the number of the circular scale division which in line with the center line, which is 47, from the total number of divisions in the circular scale, which is 50. 50 minus number of the circular scale division in line with the center line times 0.01. So error is negative. Therefore, error is negative. Negative 0.03 is the answer. Right? The error is same, value is same, but the obtaining the error is different. Okay, like we need verniers. Verniers negative in the vernier divisions starting up the adukara another coincide divisions done. Adukara is not a vernier. Same thing here, but scales are not vernier, they are circular scales. Right? Oh. So if there is a positive zero error exists with the instrument, in order to get the correct reading, accurate reading, right? Accurate reading. So what you need to do? So we always need to right? So this is the expression. To get the accurate reading, you need to subtract zero error from the reading. Right? Case is here. And if the zero error is positive, right? If you are using this expression for zero error, you need to substitute the value with its sign of it. If it is positive, here is positive 0.03. Positive into negative is negative. So error will be subtracted. Right? If it is a negative zero error, substitute the zero error with the negative sign. So negative into negative is positive. Then error will be added to the reading. අර මේක මම අර කලින් මේක දුන්නේ නැහැ කලින් වර්ඩ් එකේදී හැබැයි මේක ඕනලාම 0 එකක් තියෙන හැම එකම 0 එක අඩු කරන්න පුළුවන් අපිට අර මේ සයින් එකත් එක්ක එර එක මෙතෙන්ට සබ්ස්ටිටියුට් කරමු නේ මම වර්ඩ් එකේ දාන්නේ if the error is positive, if there is a positive 0 error, in order to get the accurate reading you need to subtract the 0 error from the reading you obtain. If there is a negative zero error, you need to add the error to the reading in order to get the accurate reading. The same thing is valid to here, right? But this is make a standard bill here. But remember, if you are using this expression, if you use this expression, you need to substitute to zero error with the sign of it, positive or negative. Right? If there is a positive zero error, you need to subtract it. Subtract value. If there is a negative zero error, you need to add it to the reading to get the accurate reading. Clear on that? Right. We got the diagram. Then you like. So we check it. Right. On the topic zero error of the micrometer screw gauge. Zero error of the micrometer screw gauge. Zero error of the micrometer screw gauge. Write down. When the anvil and spindle touch each other, the zero mark of the circular scale. Zero mark of the circular scale is in line with the center line of the linear scale. Center line of the linear scale means center line of the linear scale means there is no zero error. There is no zero error exists in the instrument. But for some reasons, when the spindle and anvil, in contact, with the center in contact, zero mark of the circular scale may not be in line with the center line of the linear scale. In this case, we say the instrument has a zero error. Zero error of the micrometer. Has two types. So one is positive zero error. First one, first one is positive zero error. First I mentioned the second one is negative zero error. First is positive zero error. The second one is negative zero error. So before we go into in detail to positive and negative zero error, you need to copy this. This is when no zero error. There is no zero error. I copy this. When there is no zero error, this must be the positions of the scales. So annual and spindle in contact. Contact is where about the common annual. Then write the next story, positive zero error. Positive zero error. Right, yeah. When positive zero error, yeah. When the spindle and anvil when spindle and anvil in contact, zero mark of the circular scale zero mark of the circular scale is at the is at the is at below is at below the middle line is at below the middle line of the linear scale is at below the middle line of this linear scale then the zero error is positive. Then the zero error is say positive. That's zero mark of the circular scale is at below the middle line. Then the error is positive. Right. So write the expression for positive zero error. Expression here. Positive zero error is equal. Positive zero error is equal. Write an expression. Write as an expression. Positive zero error is equal. Number of the circular scale division. Number of the circular scale division. Okay. Number of the circular scale division in line with the middle line. Number of the circular scale division in line with the middle line into the multiply by least count. Multiply least count. Right. So now draw the scale position. They come in. Can get the zero error. This is how the scale should be positioned where the positive zero error is there. Right. For this instrument, the zero error is 0.03. 3 is the division. But only positive error. Make a medical method. Positive zero error make a diagram relative value 0.03. Millimeters. To the side, stomach and 3 times 0.01 can be zero. Okay. Uh, reading obtained by this instrument, is greater than the accurate reading in order to get the accurate reading. Zero error must be subtracted. කලින් කියපුව දුන්නා මේක කියලා ඒක අඩු කරන්න ඕනේ කියලා නැත්නම් ඔලුවට යන්නේ ඒක zero error must be subtracted. So it is called negative zero correction, right? Within bracket the negative zero correction, we call it as negative zero correction. Right? Within bracket negative zero correction, right? Then jump up negative zero error. Next topic is negative zero error. Before that, why this positive zero is occurs? For what kind of reasons? There may be some rust or oxide or deposited on the face of the angular spindle, right? Layer dust layer, right? But negative zero, yeah. When the angular spindle, in contact zero mark of the circular scale, is at above the middle line, of the linear scale, then the instrument said to be have a negative zero error. Right. So this the reason for this is wear and tear on the face of the angular spindle, right? So this is how you find the negative zero error. Write the expression like we did previously. Negative zero error is equal. Here the expression negative zero error is equal. Writing words negative zero error equal. Within brackets, number of divisions in the circular scale, minus number of the circular scale mark, number of the circular scale mark coincide with the middle line. Close the bracket. Right. Multiply by least count. Right. So copy this one and get the negative zero error. Finished? Right after readings obtained readings obtained readings obtained from this micrometer they obtained from this micrometer is less than the accurate readings in order to obtain the accurate reading zero error must be add to the reading. Zero error must be added to the reading. Right. So it is with the brackets then it is a positive zero direction. It is positive zero direction. Right. So before we done, able to keep page number 21 for that. We can see page number 21. Question number 3. Only two parts. Question number 3, part 4 and 5. 2 weeks. 2 weeks and it's then. Question number 3, part 4 and the other way, you have part 5. Just to cement what we have learned. Page number 21 on the micrometer. Right? Question number 3, part 4 and part 5. Part 4 and part 5. Just that. So this is all about micrometer. Now all the theories are over. Micrometer is done. You need to do all the homeworks, all the exercises as homeworks, and also we have this in this tutorial. You also have the some exercises related to the Micrometer, you need to done it also. Next week I done in newcomers we have this. I complete karangen na. Complete karangen next week. So vector subject not karangen. So next week vectors will be over, and after the vectors we next week can another obtain the day is 15th of July. Needed. Alright. So we can maybe we can start the mechanics after the vectors. Vectors are big complete කරන්න පුළුවන්. ඒ නිසා දැන් ස්පෙරෝමීටර් එක කතාවලින් කියන්න. Vector start මේ linear motions start කරන්න පුළුවන්. Right, at the end of this month, there will be a unit test, right? So we will prepare for it at the end of this month. Test unit test. 290. There are measuring instruments, dimensions, right? Right, finished? Right, part 4. What is the zero error here? Is it positive or negative zero error? Positive zero error. Ne? Zero mark you can see. What is the value of the zero error? 0.02. Right, what is the reading in the scale? Reading shows in the scale 2.38, so 2.37 millimeters is the reading shown on the scale. 2.37, is that correct? 1 millimeters, 2.37 millimeters. So in order to get the accurate reading, what you need to do? You need to subtract the error 0.02. So accurate reading is 2.35 millimeters. Right, then the next one. So what is the error here? Zero error is like in this case 0.03 is the negative error. The reading shown in the scale is 2.5. You can see clearly. Thus, circular scale reading is 37. So it is 2.87 millimeters. So in order to get the accurate reading, you need to add the negative zero error. So it is 2.90. Is that 90? Ne? I make a 2.90. 90 ne? Why? Error is negative. Yes. Second, part 5 में क्या ले? मतलब ये आई कर दे मंगवा दे 37 में है මේක තියෙන ස්කේල් එක වල තියෙන මෙහෙම. උඩ තියෙනවා 0 1 2 තියෙනවා 1.5 sorry 0.5 1.5 2.5 තියෙනවා. 2.5 වල තමයි මේ තියෙන ස්කේල් එක. 2.5 exit කරලා තියෙනවා. Hey. Something. Right.